We know our Earth is shape of the Earth is geoid, good, or ellipsoid, right? You guys get it? That means it is flatter at the poles and little bulgier or little extended at the equator. That's the shape of Earth. Is not round, by the way. Those who have this misconception that Earth is round, Earth is not round. The shape of the Earth in technical terms is geoid, ellipsoid, or oblique spheroid. Okay, this is the term which you'll come across about Earth's shape when you study for your exams and navigation, and also these things will be coming. You'll be coming across these things. There's a chapter called Basic Earth in General Navigation, the first chapter, in which you'll be learning about the shape of the Earth. Some of you who took pre-DGCA, I'm not going to take any names. They did not know what are latitudes and longitudes also, but that is okay. That is why pre-DGCA classes were there for you, to tell you about latitudes and longitudes. In detail, you'll study this about in your navigation classes. Okay. So Earth's shape is geoid, ellipsoid, oblique, spheroid, right? So us humans, we are on the surface of the Earth, right? When we see an aircraft fly over, we all look at it, right? It's flying in the sky. We all look at it and we look, oh, so nice and all those things, right? Because it intrigues us. That's why we chose aviation, because it intrigues us. Seeing an aircraft, seeing it, landing, taking off, or flying over your head. We like those things, right? So it's flying in the sky. But that is a very generic or very general term, that is flying in the sky. In this subject, meteorology, you will learn about the different dimensions of the sky, different partitions, different parts of the sky. There are different parts to it, by the way. Sky is not yahan dekha bhai asman hai, that's it. It's not just sky. There are different layers in the sky. The first layer, if this is the Earth, surface of the Earth, and I'm standing here and I see an aircraft flying above me at a very high altitude. Like usually aircrafts go up to 38,000 feet, 40,000 feet also some aircrafts go. So they're flying at 38,000 feet, 36,000 feet, 30,000 feet in the sky. But they're also flying in a layer. That layer is called, which will be the first layer, troposphere. It starts from the ground and it goes up to 11 kilometers. Everywhere, no matter where you are in the world, you'll be standing on the ground. Whichever layer we are surviving right now is called the troposphere. It's going from 0 to 11 kilometers up in the sky. Aircrafts fly in this layer. Aircrafts fly in this layer. Fun fact about this layer is that it does not remain constant everywhere. It changes. Its height changes with the movement of the sun. We just named it. Humans name these things. Actually, these things are happening at a very large scale. But if you're flying in an aircraft as a pilot, don't you think you should know what is the height of the troposphere? The layer in which I'm flying in, don't you think it is important for us to know? It's quite important, right? You should know where and when it is at 11 kilometers. If I'm going to if I'm flying from Delhi to London, supposedly, London is quite far from here. It's a cold weather, right? It might be a little below, or it might be a little higher than its actual 11 kilometers altitude, the height of it. It can change. How does it change? With the movement of the sun. This 11 kilometers has been taken as an average. Why? Because we know we have a lot of countries. Every country has different weather systems, right? India falls in the northern hemisphere. Usually we are known to have a very hot and humid climate. We are not known for a cold or a winter. Russia is known for the weather, for the cold and the winters. Europe is known, not Europe, Scandinavian countries, Iceland, Holland, all Sweden, Switzerland, all these countries are known for their cold weather. They're also in the northern hemisphere. But India is also in the northern hemisphere. But it's always known for its hot weather. Why? Because it is closer to the equator. That's why. You guys know equator, right? Equator is the one which divides the earth into two different hemispheres, northern hemisphere and southern hemisphere, right? And the equator which divides it is also called as, those who took PDGC classes with me, they know this is called as the geographical equator. Remember this? A line which separates the earth into two different hemispheres. Can you see this line, by the way? We can't see it because it's imaginary. It is done for our good by the scientists or the people who really want to know, okay, you know what? All these countries, there's so many countries now. Every country has a different weather. Some of them are high up in the latitudes. These are higher latitudes. Some of them are at the lower latitudes near the equator. What should we do? They said, you know what? One of the scientists said, let's divide the earth into two different parts. They didn't go there to draw a line. It's an imaginary line they made, which divides the earth into two different hemispheres. So if there's an imaginary line which divides the earth, can there be an imaginary line in the air also, which can tell you this is the troposphere? So it's an imaginary altitude or an imaginary layer which is there in the atmosphere, where we also say where there's a temperature drop. As you go higher, don't you feel the temperature dropping? Right? Just in Delhi, it's quite hot. But the moment you go a little higher in the mountains, temperature drops. Why? Because you're going higher up. As you go high up, temperature starts to drop. Now scientists notice that also. Scientists said, guys, it's getting quite cold in the moment we are going up. So what should we do? They said, yeah, it is getting colder, but not as much as it was getting colder in that part. Because two different places might have a different variation of temperature, no? Temperature change. At some place it might be getting colder very quickly. At some place it's getting colder quite late. So scientists said, you know what? Let's take an imaginary figure. Let's take an average. That every 1,000 feet up you go, the temperature drops by 1.908 degrees Celsius. Or for calculation purpose, let's take it as 2 degrees Celsius per 1,000 feet. Every 1,000 feet higher up you go from the ground level, temperature drops by 1.908 degrees Celsius. It may not happen in real life, but this is how you measure. This is how you measure. This is something which you'll be using for your calculation purpose. When you'll be flying when you'll be flying in your flying schools, when you'll be flying in the airlines, syllabus won't change. Syllabus will be the same. Even there also you will consider it's 1.908 degrees Celsius or 2 degrees Celsius per 1,000 feet. This is one of the characteristics of the troposphere. Now, where do we measure this from? Delhi is at 777 feet from mean sea level or from the sea level. Right? Delhi's height from the sea, if you calculate, it's 777 feet. What about Himalayan states like Uttarakhand and all these places? They will also have a different altitude, right? Because they're higher up in the mountains. So we have to measure from there also. So they said, you know what? Now the sea is covering 70% of the earth, right? Water. Some countries are higher up in the latitude. Some countries are lower in the latitude. What should we do? So they said, we'll do one thing. We'll just take a mean sea level, an average of all the sea levels in the world. No matter where the country is in the lower latitude, countries at the equator, or country could be higher up in the altitude also. Like European countries, they're higher up in the latitude, right? So there, the height would start increasing if you compare it with the sea, right? So they said, we'll take as a mean sea level. Every calculation we'll do, we'll be taking, no matter if you're sitting in India or if you're sitting abroad in UK, every calculation will be done from mean sea level, an average, a static line for every pilot in the world. That pilot could be a Russian, he could be an Indian, he could be whatever. But they will all follow this mean sea level. So, if I'm standing here, be it the poles or be it the equator, every calculation I'll do, I'll be using mean sea level. Mean sea level. This is something which is set by the scientists or people who were very intrigued about these things. You know, we have to make sure that the aviation in the country or in the world makes a boost, it goes forward. But if every country will have their own latitudes and longitudes, which they have, but if every calculation is taken, now a person doing a calculation in India will have a different calculation, and the person who's sitting in UK will have a different calculation, yet they have to fly. If I'm a pilot in an Indian airline and I'm going abroad to UK, will I have to do different calculation there? No, I'll have to take the same calculation which I took from here. So I need a base for that. That base is this mean sea level. All right? Okay. So the first layer in which we basically live, in which we exist, and also the layer in which most of the weather exists is called as troposphere. Don't worry, don't write right now. Okay, I'll be dictating points. Now, there'll be a point at some point when we'll say, okay, that's enough. Troposphere, we got it. It is going up to 11 kilometers. So now we'll put a stop there. Now, how did they put a stop? How did they realize the troposphere is ending there? Sorry? Change of temperature, okay. Any guesses, guys? Good guess though. How would you know that now temperature is stopped? Temperature ceases to fall. At 11 kilometers, the temperature was dropping at how much? 1.908 degrees Celsius or 2 degrees Celsius per 1,000 feet in troposphere. The scientists who were measuring all these things, they realized the moment we reach 11 kilometers, in feet it is, by the way, 36090 feet to be precise. Actually, we said 36,000 feet, but I like to be precise. So it is 36,090 feet. Okay. So the moment they reached 36,090 feet, they realized now temperature is not dropping. It's constant. Earlier we were seeing the temperatures dropping to 36,000 feet at 2 degrees Celsius per 1,000 feet. But the moment we reached 36,000 feet, temperature has stopped reducing now. It is remaining constant. They reached at a height of 36,000 feet with a calculation of minus 56.5 degrees Celsius. So if you're a pilot flying in an airliner and if you encounter OAT, OAT is outside air temperature, which will be there on your dial. There are a lot of temperatures, by the way, on your screens, which you can see. When you fly bigger aircrafts, there'll be OAT, there'll be SAT, there'll be TAT, different types of temperatures which you study in navigation. In navigation, you'll come across this in instruments, okay, for pressure instruments. Static air temperature, still air temperature is SAT, TAT is total air temperature, OAT is outside air temperature. These are different temperatures on which you'll have to do calculations to do the numericals. Anyways, so OAT, that means the outside air temperature. When you see that it is minus 56.5, what does it mean? As a pilot, if you're flying and you reach and you see the outside air temperature is minus 56.5, that means I'm flying at the edge of the troposphere. Temperature is not going to fall now. It's going to remain minus 56.5. Can anybody take a guess? Till what height will it remain? Minus 56.5. 7? How much? 6. In kilometers, how much would it be? 20 kilometers roughly? Roughly 20 kilometers. That means from 11 kilometers till 20 kilometers. Now we can also say as 65,000 feet or 66,000 feet. But again, I like to be precise. So the actual height is 65617 feet. 65,617 feet. The temperature will remain constant at minus 56.5 degrees Celsius. Now all this part is called what? Tropopause. Good. It's called as tropopause.